Good day, everyone. You are welcome to the physics branch of Mathematics Solution Center. Today, we are going to be looking at the derivation of equations of motion and basic hints. And we are going to solve some examples so that you can see how to apply these equations of motion. I promise you, after you have listened to this tutorial and you apply everything that is going to be said inside it, then I promise you, you will never miss a question under equation of motion again. Okay, let's go. The first thing we are going to do is to define our parameters. Time represents with letter T and is measured in what? In second. Time is just a kind of duration of an event. Anything we want to do in life have to do with what? With time. That is time. Then we have a velocity. Our velocity is going to be into two parts. We have the initial velocity, which will be represented by letter U, and then the final velocity, which is represented with what? Letter V. Velocity is the rate of change of displacement with time, but most of the time we are going to be what? Interchanging the word velocity and speed together, but they don't mean the same thing in the real sense. Speed is the rate of change of distance with time, while velocity is the rate of change of displacement with time. The difference between them is that speed is a scalar quantity, while velocity is a vector quantity. Another parameter we are going to be talking about here is acceleration. Acceleration is the rate of change of velocity with time. Acceleration can be grouped into two, the negative acceleration and the positive acceleration. We'll talk about this positive and negative acceleration later. Distance. The distance covered by an object will be what? Represented with the letter S, and it is measured in meters. Okay. The first thing we are going to talk about now, average velocity. Average velocity. If an object has an initial velocity u and a final velocity v, what is the average velocity of this object? The average velocity, just like we calculate average in mathematics, is going to be equal to what? Initial velocity plus final velocity all over what? All over 2. So average, sum, divided by the total. That is average. Okay. Don't forget that velocity, average velocity is equal to what? Distance over time. Now let's make a distance the subject of the formula. Therefore, we have distance is equal to average velocity times time. But my average velocity is given in times of what? Initial velocity plus final velocity over 2, then times time. This is our number one equation of motion on a straight line. The next equation of motion, acceleration, is what? Is the rate of change of velocity with what? With time. This change of velocity is the same thing as what? Final velocity minus initial velocity over change in time. Now let's make V the subject of the formula. I have V is equal to what? U plus AT. This is my equation 2. Now we are going to do something. We are going to substitute this equation 2 in equation 1. This is my equation 1. Anywhere I see V in equation 1, I will replace it with what? U plus AT. And that's what we are going to do now. So S is equal to U plus, instead of V, I will write U plus AT all over 2 in bracket T. Now let's work on this further. We are going to have S is equal to what? 2U plus AT all over 2, then time what? T outside. Now let's open the bracket with T. I have S is equal to 2UT plus AT squared over 2. And let's divide through by 2. We have S is equal to 2UT over 2 plus AT squared over 2. 2, we cancel 2 here. And then we are left with S is equal to UT plus half AT squared. So this is equation 3. Equation 3 gotten, and then the last but not the least is going to be gotten from equation 2. Equation 2 is written as V is equal to what? U plus AT. What we are going to do to this equation 2, we are going to square both sides of equation 2. Squared and squared. Therefore, I have V squared is equal to U plus AT. Then U plus AT again. Then we are going to expand the right hand side. V squared is equal to U into bracket U plus AT. Then plus AT into bracket U plus AT. Okay, let's continue with our expansion. U times U is actually U squared plus AUT plus AUT and plus AT squared. Let's continue. So we have V squared is equal to U squared. AUT plus AUT is actually 2AUT, then plus A squared T squared. Okay, now we are going to work further on this expression. V squared is equal to U squared plus, we have 2AU, TAUT, and plus what? A squared T squared. We are going to bring out 2A from these remaining terms. 2A, and we are left with what? UT, then plus 1A has been taken, and we are left with what? AT squared. Or we are going to divide it by 2 because there's no factor of 2 there. Whenever you factorize, you divide what you have inside by what you have brought out to get the remaining thing. Just like 2AUT divided by 2A, we are left with what? UT. A squared T squared divided by 2A, we are left with what? AT squared over 2. If I should try and multiply, open this bracket by 2A, I'm going to get 2AUT, then A squared T squared, because the 2 will cancel the 2 right here. Let's continue. Now, if you look at everything inside that bracket, we have a V squared is equal to U squared, then plus 2A into bracket UT plus, you can write this as half AT squared, bracket close. If you look at this, let's go back to equation 3. What we have as our answer, look at equation 3 here. That is what we have as our answer here. So equation 3 is actually what? S is equal to UT plus half AT squared. Let's go back to that. You will see that it is what? UT plus half AT squared is actually our S. Therefore, we can rewrite this equation as what? V squared is equal to U squared plus 2AS. This becomes our what? Equation 4. Now let's write all these equations we've derived out. We have S is equal to U plus V over 2, then T, equation 1. The second one is what? V is equal to U plus AT, equation 2. Now I want to advise you, try everything possible, learn how to derive these equations, and at the same time, know the equations offhand without taking reference from anything. Always be able to write these equations, no matter what, no matter where you find yourself. And the last but not the least is V squared is equal to what? U squared plus what? 2AS. Equation 4. These are the 4 equations of motion. And S is equal to U plus V over 2 times T. Then V is equal to U plus AT. S is equal to UT plus half AT squared. And V squared is equal to U squared plus 2AS. Now we are going to solve questions using these equations of motion and see how it goes. Now let's take a look at the hints. What you need to put into consideration always when apply this formula. Number 1 is about your U and your V. U, whenever you hear that an object starts from rest, please immediately just take U to be 0. You don't need to be told. An object starts from rest, take U to be what? 0. And once you hear the fact that what? An object comes to rest, the final velocity of the object is what? It's 0. When a driver is driving, applies the brake, and the car comes to rest. Take your V to be equal to what? 0. These 2 points are very, very important. The next thing is about an acceleration. Acceleration can be positive and acceleration can be negative. If you hear a car accelerates, the velocity increases from initial velocity to the final velocity. Acceleration is positive whenever there is a what? An increase in velocity. But acceleration is negative when there is decrease in velocity. V is equal to U plus AT. If acceleration is negative, this equation changes to what? U minus AT because of the value of the negative acceleration. When a car is retarding or decelerating, take acceleration or whatever that is given to be what? Negative, unless it is the retardation you are calculating. If you are calculating retardation or acceleration directly, leave it the way it was, like this. But you are giving acceleration, and the acceleration is the fact that what? The car is what? Coming to rest. The car comes to rest at the rate of what? 2 meters per second square. Take it to be negative. Please, don't forget this. It is very, very important. This is a mistake most students find themselves because they always want to take this formula like this, that it must always be like this. Nothing should change it. No. Listen to the fact that what? Acceleration can be negative and acceleration can be positive. When the velocity increases with time, acceleration is positive. And when velocity decreases with time, acceleration is what? Negative. Let's take a look at a question here. Okay, we have a question here that says a car starting from rest and moves with a uniform acceleration of 30 meters per second square for 20 seconds. Calculate the distance at the end of the motion. Okay, from this, a car start from rest, we've already said or concluded that what? The initial velocity is 0. Therefore, I will quickly write U is equal to 0. Moves with uniform acceleration. Acceleration is given for 20 seconds. My acceleration is what? 30 meter per second square. And then T, time is what? 20 seconds. Calculate the distance covered at the end of the journey. Okay, now you have this. Which of the equations are you going to use? And the only equation we can use there is S is equal to UT plus what? Half AT squared. That is the only equation we can use here. And we are calculating distance. S is equal to our initial velocity 0. 0 times T remains 0 plus half. What is my A? Is 30. 30 times 20 squared. 2 goes in 30 is actually 15. I have 15 times 20 squared. That is 400. Therefore, I have S is equal to what? 600. So the distance covered is actually equal to 6,000 meters. Therefore, S is equal to 6 kilometers. That is the distance covered. Now let's take a look at another question. The next question goes like this. A car traveling at this. That means our initial velocity U is equal to 20 meters per second. Is brought to rest with a constant deceleration of 10 meters per second square. So it's brought to rest. Our acceleration is equal to what? Minus 10 meters per second square. Don't forget, it is brought to rest. It has an initial velocity of 20 meters per second. It is then what? Brought to rest. It decelerates to rest. Acceleration is negative here. Calculate the distance and traveled. So what will be the distance what? Traveled. And I will also add the time it takes to what? Come to rest. Okay. Now, which of the equations of motion we are going to use? And don't forget, for the fact that the body comes to rest, I will quickly also write that V is equal to 0. Please always have this at the back of your mind. If you look at these 4 parameters, initial velocity, acceleration, final velocity, and distance, the formula I can use here, I will use V squared is equal to what? U squared plus 2AS. This is the right formula to use. Final velocity is 0, is equal to initial velocity, which is what? 20 squared plus 2 times minus 10, then times what? The distance covered. Don't forget, acceleration is negative. Therefore, I have 0 is equal to 400 minus 20s. Therefore, I have 20s is equal to 400. Divide both sides by 20. I'm going to have 20 meters. So this is the distance covered during the journey. Okay, we can also calculate the time. We quickly use this formula. V is equal to U plus what? AT. My final velocity is what? 0. And is equal to what? 20 minus 10t. My 10t is now equal to what? 20. Divide both sides by 10. We have t is equal to what? 2 seconds. This is the time. This is the time it will take the object to come to rest. I can still calculate this time using s is equal to ut plus what? Half at squared. If you use this, you will still get your what? Your time to be what? 2 seconds. But this, you are going to be working with what? What is called a quadratic equation, because it is quadratic. You already have your s, and then you can also use it to calculate the s we calculated initially, because we already have the time now to be 2 seconds. All you have to do is to substitute here. Thank you for watching. We have come to the end of this tutorial. Please don't forget to apply the hint, everything you heard. Don't forget to apply them, because it is going to really help you a lot. Take initial velocity to be always 0 when a car starts from rest. When a car comes to rest, final velocity is 0. When a car accelerates, always remember, acceleration is positive. And when a car decelerates, acceleration is negative, and apply it in your solution, in your calculation. I told you the only condition whereby you don't need to take acceleration to be what? Negative is when you are calculating the acceleration itself. But you are not calculating acceleration and you hear the word decelerate or retard. Take acceleration to be what? Negative. Thank you for watching. If you have any question, don't forget to put it in the comment section. And if you have not subscribed to this YouTube channel, please, I use God to beg you. Support me by clicking the subscription button, so that this will encourage me. And also don't forget to like the video, share it, and then put on the notification button so that you will be notified anytime we upload a new video. Thanks and remain blessed.